Alright, so let's talk about limits at... Okay, so let's talk about limits at infinity. So this is the idea that you're trying to take the limit of a given function as x approaches an arbitrarily large number, whether it be large positive or large negative, but you're talking about let x approach infinity. So let's start with this example. If I were to try to find the limit as x approaches infinity of the function 4x cubed plus 1 all over 2x cubed, plus the square root of 16x to the 6 plus 1. The idea is you want to think about as x approaches arbitrarily large, what's going to happen to this entire function, try to recognize a pattern. And then a good algebraic pattern tool to use would be to multiply top and bottom of this function by 1 over and then x to the power of the highest power of the bottom. So in this case, we're thinking about the highest degree on the denominator, which would be x cubed. But notice that x cubed is in fact the same thing as the square root of x to the 6th. So that's something that we can keep in mind to help us combine things. We can use the one that has a square root for those that have a square root, and then the one that doesn't have a square root for those that doesn't. And notice that this is true when x is positive. So this is true when x is a positive number. The reason why you really want to notice that is because when x is positive, x cubed is still a positive number, and then x to the 6th is still a positive number. So that's why that equal sign holds true, which is nice. So that's something to keep in mind. So that's what we're going to do. We're going to go ahead and multiply top and bottom by this 1 over x cubed. So let's go ahead and do that and see what happens. You want to be able to reduce each one separately as well. That's going to be the goal. So if I were to go 1 over x cubed, just like this. Now 1 over x cubed for the top, what's going to be nice is we can realize that nothing's under the square root, so that works out well. However, for the bottom, you do want to think about what's going to happen for the things that are underneath the square root, so we just have to be careful with that. So this is going to become the limit as x approaches infinity. On top, we'll have 4x cubed times 1 over x cubed, which is just 4, plus, and then 1 times 1 over x cubed. So what I did is I took each one and I distributed on the numerator. So I multiplied on the top and on the, for the top I multiplied the 4x cubed and the 1 by that fraction. Now I need to do the same thing for the denominator. So I have 2x cubed times 1 over x cubed, which will turn into just 2, plus, and now what we want to think about when we're distributing this 1 over x cubed for the square root, it's actually going to become, instead of 1 over x cubed, it's the same thing as 1 over, oh, let me give you a color that you can see. It's the same thing as 1 over the square root of x to the 6th, rather than the 1 over x cubed. That way we can actually combine the square roots, which just makes it easier. So the square root still stays, it's just that now everything can in fact be underneath the square root. So 16x to the 6th times 1 over x to the 6th is just 16, and then plus, and then I have a 1 over x to the 6th. So that simplified it, and then based off of what we know for our limit laws, we're allowed to take the limit of each of those fractions separately. So 4 is just going to go to 4, but 1 over x cubed is actually going to approach 0 as x approaches an arbitrarily large number. Think about as x approaches really large, x cubed will also be really large. So 1 over a large number approaches a small number, the same thing for 1 over x to the 6th. So then we're able to get a final answer, which will be I had a 4 on top plus a 0, and then a 2 plus the square root of 16. And so that's where we're going to end up with 4 over 2 plus 4. So you can have that 4 over 6, or simply 2/3. So that's going to be the answer for this particular question. That was the limit as x approaches infinity. So then the next question would be to try to figure out what's going to happen when we take the limit as x approaches negative infinity. And so that's going to be a little bit different. What we talked about before is we said that x cubed was the same thing as the square root of x to the 6th. However, that was only true when x was positive. So that's going to be an issue. What happens when we have x to be negative? Well, then this is going to be a big issue. So let me think about what's going to happen when x is negative. When x is negative, x cubed is also a negative number, but x to the 6th would be positive. So this equal sign is not a true equal sign. Now we need to be able to make that an equal sign. And in order to do that, we're going to go ahead and pop an extra negative in front. So let me show you that, which means now I have a negative x cubed. Now, you're thinking x is approaching negative infinity. So x is a negative number, which means since x cubed is negative, this negative and this negative will cancel each other out, so you'll end up with a positive. So in fact, negative x cubed will be a positive number. And x to the 6th, as you know, anything raised to the power of an even number will still be a positive number. So that's now our true equal sign. So now what we're doing is we're still going to multiply top and bottom by 1 over x cubed, but we have to be careful. We're multiplying top and bottom by 1 over negative x cubed so that everything can be positive. So the 1 over negative x cubed is going to work for the top. The 1 over negative x cubed is going to work for this first term, but then the 1 over the square root of x to the 6th without the negative, because that one doesn't need a negative, it's already positive, will work for the square root. So let's go ahead and rewrite that to see if we can make a little bit more sense out of that. So now we have the limit as x approaches negative infinity. Our original question, the 4x cubed plus 1. Now this guy is what's going to be multiplied. Now that's our numerator. That one, nothing was under the square root, so it doesn't need the square root, but it does need the negative. And again, that's because we needed an extra negative in front of our x cubed, so that's important. Okay, and then we have we need the denominator now. So the denominator had a couple of different things. The first term the denominator had was a 2x cubed, and the 2x cubed is going to have to be multiplied by the negative 1 over x cubed because it's not under the square root, so it needs the term that's not under the square root. And then the rest of the denominator, which was the plus, I had a 16x, square root of 16x to the 6th plus 1. Now that's the one that's not going to need an extra negative, because I'm going to multiply by 1 over the square root of x to the 6th, which is already positive. So everything that's in red right there, as x is approaching negative infinity, everything that's in red is a positive number. So I've multiplied top and bottom by the same thing, by the same positive number. So then we have to go ahead and reduce the limit. So that's going to become, I have now the limit, sorry about that, the limit as x approaches negative infinity. On top I have a 4x cubed times negative 1 over x cubed, which is just negative 4, and then a positive 1 times negative 1 over x cubed, so that one's going to turn into a negative. All right, and then I'm going to have on the denominator a 2x cubed times negative 1 over x cubed, which became a negative 2. And then that square roots, everything under the square root stayed the same sign because x to the 6th, again, was already positive. We didn't need to force it to be positive. So 16x to the 6th over x to the 6th was just 16, and then plus 1 over x to the 6th. And we don't need another square root right here because it's all underneath the bigger square root. So that's enough for that. Okay, so then we go back. Now that we've simplified it, we now know with limit laws we can take the limit of each one separately. We're taking the limit as x approaches negative infinity. So this x cubed on the bottom will become very large, which means 1 over x cubed is going to in fact approach 0. So this entire fraction will approach 0. And same thing with this entire fraction. That's going to approach 0. So that's what we're left with so far. So on the top, I now have a negative 4 minus 0. So I had a negative 4 minus 0 on the top. And if we go back and look on the bottom, I had a negative 2 plus the square root of 16. I had a negative 2 plus the square root of 16, and there was another plus 0 there, but plus 0 isn't going to change anything. So I ended up with negative 4 over negative 2 plus 4, which is the same thing as negative 4 over 2 once you've combined that denominator. So now we had a negative 2 as an answer. So you did have two different answers here, and it all came from that square root, which is kind of interesting. When you're approaching a negative infinity, that could possibly change some things. So that's what we got when we were approaching negative infinity, and then that's what we got when we were approaching positive infinity. So two different answers for our end behavior here. So that's a good example of limits at infinity, as x is approaching a very large number.